Hi, and welcome to our presentation of our design for our Engineering 314 class. We are making a rover named Meg. So we want to build an all-terrain rover that can go to difficult, maybe unsafe or inconvenient places for human access, while also gathering real-time data. Our mission is to develop a reliable and a modular rover platform that supports safe remote exploration while emphasizing structured system design, clear communication between modules, and strong engineering practices. So this website is our full engineering process from our initial team organization to our concept design to our requirements for our project to our team block diagram and even more information than that. So this shows how we as a team organize our subsystems together and how we plan to build our robot Meg. So our team structure is around a subsystem ownership system. So this will ensure clear responsibility of who needs to do what, and it creates efficient progress throughout our project lifecycle. Each member has their own subsystem where they dive deep into their research, and we get our own subsystems working before trying to integrate ours with others. This will simplify troubleshooting when issues arise, knowing what the difference is between one board to another, what information is traveling and not traveling in the case of a troubleshooting issue. And each member has their own specific subsystem. So I am the controller module. We have two drive system modules. We have a sensor module and a camera module. We hold weekly in-person meetings, and in between those meetings, we also share things on GitHub to work on version control and tracking for all of our different subsystems and team progress, as well as we have other technical discussions and coordination on shared messaging platforms. Hardware and software are developed in parallel with each subsystem. So as someone is developing the hardware for their system, they're also developing the software for their system. There's more information on our team website about our organization, of how we organize our team, and more about our team in general and our goals with our subsystem. Thank you.
For Meg, our top two concepts were almost exact opposites. The designs were built for different environments in mind. This one was built around the idea of an urban environment where it would need to be more personable and be able to interact with humans in a shorter distance. And our other concept was built in mind of harsher environments, something more of the traditional uh, exploration of a harsher environment where there are no people and there would be more obstacles and you would be farther away from the actual rover. So the difference in aesthetics was very big, and we picked this one because it felt that there were more situations to actually apply it and actually use it as an exploration device.
Hi, my name is Tim. I'll be doing the project, going over the project requirements. All it basically is that we did a table listing all the things that we want or could want on our project, which is the navigation robot. So we listed a bunch of ideas that we could have and the purpose of it and whether or not it will be a stretch or not. The difference between having it a stretch and not a stretch is not a stretch is that we have to have it. It's definitely a need. A stretch would be something that we could live without. So it's something that we don't necessarily need for our project. So we list for each of our subsystems, we listed all the possible things that we could have, all the safety features, everything. We made a design matrix, and then we finally kind of gave a general criteria which established stable wireless communication with the controller and laptop, provides a continuous live front camera feed, response to controller input with observable drivetrain motion, successful traverses a defined obstacle path, displays temperature and humidity readings on a laptop interface, detects nearby obstacles, and activates the usual or audio alert. Also operates on battery power for a minimum of 10 continuous minutes. And finally, immediately halts drivetrain motion when the emergency stop is activated. So these are the requirements, the criteria that we for sure want while building our robot.
Hello, I'm Riley, and this is our daisy chain communication connection for our team block diagrams, at least the first part of it. Um, so I will start with myself. My uh, subsystem is a humidity sensor. I'll be taking that data and sending it downstream to Hattie, the second board, um, through the UART. My non-standard pins for this connection, I have them as a way to send additional information, just in case it's needed at some point later down the line. Hattie's subsystem is a camera subsystem, so she'll be receiving the data that I send and publishing it along with her own camera footage to um, a website or app or something similar so that the user is able to see it. Um, she is sending and receiving data to also Riley. It's a different Riley. I'm sorry. Um, who is in charge of a temperature sensor as well as the control system for the rover. Um, she is sending information back upstream to Hattie's board in order to tell the camera subsystem when to take a photo. In addition, she is sending the controls downstream to the two motor subsystems.
Hi, I'm Bryce. I am doing a motor subsystem, and I am receiving again his other Riley is sending me uh the controls for the motors, like to move them around. I have extra pins for I can guess we want to send signals to one another, and then I'm sending back out the control that goes to Tim's board, who is also doing a motor, probably part of like our drivetrain, and then he is uh yeah, receiving that signal and then also UART for wherever we need to communicate, and then outputting extra pins for in case we need to send a signal to each other. And then he connects to Riley's board, who then receives whatever signals he gets sent, and then process continues. Hence the daisy chain.
Thank you.